8 o'clock now. I think we can start. So last time, as I told you before, chapter 2 is just a revision on network 1, so that we can start after chapter 1. We are going to start new topics. So in the last section here, last time I started to explain the idea of layers. Okay. So as you know, we have here in network, we have the very famous 7 layers, as you see here. Physical, data link layer. Sometimes we call it layer 1, layer 2, layer 3, or data link layer, network layer, transport layer, session layer, presentation layer, application layer. And as you know, in TCP/IP, actually what they did, these 2 layers, they combine them together, and it's called host to network layer. Instead of network, we call it internet layer. Transport here is still transport. And we actually cancel these 2, but if you need the functionality of these 2, you can actually put it as the application layer. You can put it here in this layer. Okay. So here, for example, as you see here in this figure, we have here a computer A is connected to computer B through two routers, as you see here. Okay. So for example, here the data starts from the application layer. So the application layer sends the data to the presentation, session, transport. It's going to go all the way until the physical layer. The physical layer is going to transmit it to the next hub. The next hub here is a router. And then the router this data is going to go up until the network layer. The network layer is going to send it to next router here. As you will see in this course, or also as I'm going to explain, the network layer is responsible for routing. It should decide if I receive a packet, how I'm going to route, or how I send this packet, so that the route is delivered to the destination. Anyway, so and then now the network layer has to decide where it has to send this signal or this packet to get it delivered to B. So what happens here, as you see, so it's going to go down here all the way to here, and then you are going to send it from here to here. Same thing here. So the packet should be received by the physical layer. It has to go up again to the network layer. The network layer has to decide where it has to send it. So here in this case, it has to go to the destination this way, and then it has to go up until the application here. So as you see here, there are several things we need to talk about here. The first thing is, in the first 4 layers, these layers, the upper 4 layers, actually they are end-to-end. So this layer, application layer, is communicating to this application layer. Okay, same thing, transport to transport. So they are end-to-end. We don't need this layer in the middle here. We don't need them here. Okay, simply because, for example, application, we don't have application here. Your application is here. You understand what I'm saying? So all the routing has to do just forwarding or routing the data. That's why all what we need only is the first 3 layers. Okay. Yeah. Here comes the idea of encapsulation and decapsulation. So what encapsulation means, for example, as we see here in layer number 7, we have a message here. And then this message, as you see here, is going to be sent to the next layer. Next layer is going to add some control information. I'm going to call it header 6. And then also same thing, layer 6 is going to send to layer 5. Layer 5 is going to add also some control information. And then, so as you see here, that's why you call encapsulation. So you add one layer, as you see here. So header, okay, and so that's what happening here. And the other side, I'm gonna remove these layers. Okay, so what happens here after, as you see, because as you know in this course, we are gonna focus on the first 3 layers. We are gonna explain them in some details. So in the second layer, as you see here, is gonna add header and tailor. Okay, at the end here. But anyway, so what happens here, as we see, So actually, this header and this tailor is gonna be who's gonna read them. The header, this header, the corresponding layer here is gonna read them, and then it's gonna remove them and send this packet up. Okay, same thing. The header you put it here at layer 3 is gonna be read or is gonna be needed by layer 3. Same thing. The layer you add here for layer 4 is gonna be used here. Okay. So no one can understand this one except this layer. So here when I add this header, so this header actually for this layer. That's why this layer is gonna remove after using it, it's gonna remove. Same thing here, you add here a header, and this header also is gonna be removed, as you see here. Okay. Yeah. Yes. So it's just to some control information. So later in this course, you will understand what we put here in the headers. Okay, some control information like the source address, the destination address, some other information as you will see. Okay. So anyway, any question here regarding the idea of encapsulation, decapsulation? So encapsulation means every layer is going to add a header. Decapsulation, removing the header at the destination. Okay. Also, you should understand this header is going to be used by the corresponding one here. And once it is used, I'm going to remove it because once it is used, so I'm going to remove this header as you see here. Okay. Also, I already explained the idea of segmentation or reassembly. I already explained it. When you cut the message into small packets and then you reorder and reassemble them. As I told you, layers, the upper layers, 4 to 7, they communicate with the end-to-end. So these layers are actually end-to-end, as you see here, the upper layers. But the lower layers, 1 to 3, communicate with the same layer on the next hub, as you see here. So the first layers here, first 3 layers actually from here to the next hub. The other layers are end-to-end. I think you should also, I explained it before, you should understand when I say end-to-end. So this is one end, and this is the other end. Okay, this is one hub, another hub. So you should understand when I say end-to-end, what it means. When I say in every hub, what it means. Okay, every hub means from here to here, from here to here, from here to here. We have another hub here. Okay, but end-to-end means from the source to the destination. Okay, so I already explained last time why you made it this way, why you made it the idea of layers, because it's going to be too complicated. It's going to be it's very simple. Okay, I give several reasons here, but all of them is about if you put everything together, we do a lot of things. If you just do it at once in one layer or one, so it's going to be too complicated for sure. And that's usually what you do. If you have a very complicated test, you divide into small tests. Okay, this is one of the reasons. The other reasons actually is if you change, it's going to be easy to change one protocol. For example, here, so it's changing one. If I use here, if I use a certain protocol here at the data link layer, okay. If I use a certain protocol here in the data link layer, if I change this protocol, I don't need to change the protocols of the other layers because they are independent. You understand what I'm saying? So here, if you can change the protocol here without affecting the other protocols. Okay. Anyway, so there are several reasons why they made it this way. Okay. So it's going to be easy to update protocols without affecting the other protocols and so on. Now I'm going to go through the layers one by one, just to make very quick revision about what's happening in these layers. So let's start with the upper layer, layer number 7, application layer. You can tell from the English name, application. This is where you run your application. So actually, your program here is going to communicate with the program here, and this is actually. This is a purpose of networking. The purpose of networking, actually, you have a computer communicating with a computer to be more accurate. It's not a computer communicating to a computer, to be more accurate. It's actually a program here is communicating with a program here. You understand what I'm saying? Yeah, there is a difference for sure. So it's not about yeah, sometimes we say computers, but to be more accurate, is actually you have a program here, okay, and you have a program here, and they are communicating together. Okay. So as you know, in the application layer, we have several protocols, very famous protocols. We use them all the time. Like, for example, here, I think I list HTTP. We use it all the time for web to websites. We have SMTP. This is for email. We have file transfer protocol. This one is used to transfer files. Okay. And DNS protocol, also DNS. Can anybody tell me what is DNS and how we use it? DNS? Yeah, how we use it? Yes.
That's the IP address that you are.
That's true, because, okay, so for example, if I want to go to any website, I should remember the number, every IP, the IP address of this website. Is that okay? For sure, for us as humans, which one is better for us, to remember names or remember numbers? Names. Okay, that's why it's very easy. For example, if I want to go to, for example, Google, I'm going to say www.google.com. Okay, that's easy, right? However, the network doesn't understand what is this. So we need to convert this one to number. Okay, it's just a bit more convenient for us to use names instead of numbers. So what happens once you write the URL here? Yeah, so we need actually the DNS is gonna change it to IP address. So you don't need to memorize numbers. That's it. Okay. Anyway, so here, so as I told you, actually, when we have, as I'm gonna be clear, yeah. So if you have a computer, in this computer you have programs, and actually here one program is communicating to another program, or we are gonna call it a process-to-process communication. Process means any instance of the protocol or a program. Okay, so actually whatever data here, this is the human, the user is here, you are going to use this application, you are going to send the data, whatever you are going to send here is going to go to finally, so it's going to go through several things, and at the end program is going to send the data to another program. This is very high level to what's happening. Okay, any questions? Okay, great. In the second layer and third layers, as I told you, in TCP/IP, we don't have them anymore. However, anything I'm going to mention here, you can put it in the application. Still, you can do it, but not in a separate layer. You can put it in the application layer. For example, presentation layer can be used, for example, if you want to do some kind of a compression, if you want to do compression to the data, if you want to do changes the data format or something like that. So this can be done by the presentation layer. But again, as I told you in TCP/IP, you can still do the same thing, but you can put it in the application layer. So after you get data from the user, you can do the compression, all of that in the application layer. Next layer, we call it session layer, same thing as well. This layer is canceled in TCP/IP, but you should be careful here. When I say canceled, it doesn't mean I don't need. No, what I mean, what I used to do here in a separate layer, still I can do it, but in the application layer. Okay. So for example, this one, you can tell from the name session. So this one can be used to set up a session, like you can do some kind of authentication, whatever. You can do it in this layer. So now, if you want to do something like that in TCP/IP, you can do it in the application layer. Okay. So very important point here. The applications, the presentations, the session layers are actually concerned with application issues. So the upper three layers focus on the application itself. It's not about networking. It's not about routing. Okay. It's not about communication. It's mainly about the application. Okay. So here in the first one, this is the data of the protocol. You may need to do like compression or whatever. So this is mainly for the application. Nick, starting from layer number 4, we are gonna start to focus on network connection, how to create connection or networking. Okay, so one of the very important layer is the transport layer, very important layer. I'm not sure I'm not sure if you have studied this layer in some details in network 1. So you know the idea of congestion control when you start with a very high transmission rate, and then once you don't receive acknowledgement, you assume, because I didn't receive acknowledgement, you can assume there is a congestion, and then you are going to reduce your transmission rate. Yeah, so you already have, you know it, right? Okay, yeah, because this one was a very important. So now I'm going to start. So again, as I told you, layer 1 to 4 is about connection, how to create connection. 5 to 7, as I said, it's mainly focusing on the application itself. Okay, anyway, so actually transport layer here is actually here. First of all, we define the port address. As I told you before, we use three different types of addresses. We have MAC. You should understand the difference between them. I already explained MAC and IP. MAC and IP. Now we have the port number as well. Okay. Any address is identified, so it has to be unique. That's true. Identified. Okay. But the difference is, as I said before, MAC is identified inside the LAN. Okay. So inside, we use it only inside the LAN when we communicate with each other in a LAN. Okay. And it is actually used by layer number 2, by data link layer. This IP, it has to be globally unique, as I told you before. Okay. And the MAC address, sometimes we call it physical address. Physical, because as I told you before, every device has a unique, not only one MAC address, and it is portable. What do you mean by portable? It means if I come to Qatar University here, my laptop, this laptop is going to have a MAC address. When I go home, it's going to have the same MAC address. It's portable. You got what I'm saying? Same thing. This one has its own. You can't change it. Okay, it's portable. Okay. However, the IP address is related to the location. So when I come here, I'm gonna get a certain IP. When I go home, I'm gonna get a different IP. Is that okay? Also, as I told you before, the IP address has to be have hierarchy, similar to the mailing address. Okay, so it has to be some. I think we are gonna address in details in one chapter here. So if you look at the address, you see there is a part similar to country. We have a part similar to a state inside the country. We have a part similar to whatever. You got what I'm saying? Hierarchy. That's why if you look at all addresses for Qatar University, all IPs, you can find there is one part that's common in all of them. You got what I'm saying? And the reason we made it this way, because we have a very serious concern. How many IPs we have? Too many. It's globally. Okay. So we have too many. And how big the routing table? If you make it flat, it's not going to work. If you make it flat, because the routing tables are going to be too long. So the idea here, I don't need to record. I don't need to store all addresses in the routing tables. Or it's going to be make the routing table much more simpler, because all what I'm going to say, if the first 4 bits are these numbers, that's it. So I don't need to list all of them, all the addresses. I'm gonna just look at one part. It's similar thing if you have letters. If the country is Canada or whatever, or Saudi Arabia or Kuwait, or whatever, if this is the country, okay, so all of them, I don't need to read the rest. I'm gonna just look at the country. Okay, so collect all of them and send them. So this make it easier. Anyway. The other thing here, and this one has to be globally unique, as I told you, but the port address has to be unique inside the computer. Every application has a different port. You got what I'm saying? Because as I told you, when we have computer, so when you send the data to the computer, we say computer is communicating to computer, but this is not accurate. Actually, it's application is communicating to application. You got what I'm saying? So once you deliver the data here, we have different applications. You got what I'm saying? We have different programs. Maybe we have different programs. All of them are sending and receiving data. So now once I receive the data, I need to decide if this data has to go to this program or this one or this one or this one. Okay, so that's why we use here the port address. So every program, or we call it process, every program here has a unique address. We call it port address. Okay, yes.
But the diffusion layer is using the points.
Okay, that's a very good question. Simply because the first three layers, they don't care about connections. I don't care. Okay, I only focus on, so I don't care about ports. I don't care about all of that. Only I care about application. Okay, who's gonna take care of connecting? Connecting one program to one program is this layer. This is the responsibility of this layer. You got what I'm saying? Who's responsible to, yeah, I think this is very important slide. I wish you understand it. So network layer is actually for connecting or for delivering host to host, computer to computer. The network layer doesn't know or doesn't care about, or doesn't know the port number or which application is communicating to which application. It's not its responsibility. The responsibility of the network layer, just if I'm going to take data from this computer to this computer, that's it. The upper layer, which is transport layer, will decide once this data is delivered to this computer, should it go here or go here or go here. This is the responsibility of the transport layer. That's why it's very accurate to say, and it's very important to understand, the network layer is actually computer to computer delivery. I just care about, I'm going to take data from this computer. My responsibility is just to send it to this computer. That's it. Okay. And then the upper layer will decide to which application has to go, which is the transport layer. So that's why transport layer is going to take care of delivery of process to process from a program to another program here. Is that okay? That is why here, because this one is about computer to computer, that's why this one is going to use the IP addresses. So the IP addresses are used here, okay? Because this one is actually process to process, that's why this one should use the port address, port number. Port number is used here, okay? For layer number 2, is going to be, we're going to use the MAC. So the MAC always used in layer number 2. No other layer will use it, okay? IP is used in layer number 3. No one else will use it. Port layer is used in the transport layer, because this is the responsibility of the transport layer, is to connect program to program. And to connect program to program, I need to connect the computer to computer. And to connect the computer to computer, I need to connect the computer to one hub. One hub to one hub, one hub to one hub. That's why every layer is going to help the other layer. Every layer is gonna actually use the service of the other layer. So let me also, this you should understand this part. So if I wanna connect process to another process, this is at the transport layer. I need the help, or I need the service of the network layer to connect to computer to computer. To connect the computer to computer, okay, I need layer number 2 to transmit it from one hub to one hub. Okay, so that's what you should understand. So every layer needs the help of the other layer. Okay. So this layer actually, yeah, this is one of the most important layers because there are a lot of things happening here. So number 1, this layer defines the port numbers are used here. This is number 1. Number 2, this layer is actually about process to process. It's going to take from one program connected to another program or a process on the other computer. Number 3, segmentation is done here as well. You do the segmentation, okay, and reassembly at the other side. Also, congestion control is done here. Congestion control is done in this layer. Flow control is done here. Okay. Also, they do error control, but be careful here because look here. as you will see in this course. So in this layer is end-to-end, is end-to-end. So when I say error control, it means end-to-end. When I say flow control, it's going to be end-to-end. Okay? As you will see in this course, as well here, in one hub, we are going to do also error control. Okay? Also, we are going to do flow control. Okay? Because errors can happen here when you transmit from here to here. Also, we have a flow problem here. So that's why flow control is going to be done here, but it's going to be end-to-end. We have here also flow control. Okay, congestion here we don't have congestion control. The problem with congestion control is not here. We have the congestion control is here. Okay, that's why we don't have congestion here. Okay? We have flow control, not congestion control. So there are two very famous protocols. We use it here at the transport layer, which are, yeah, that's what I'm saying here. End-to-end flow control, okay? As I told you last time, I explained last time, I'm expecting that you understand the concept or the meaning of congestion control, the concept of flow control, okay? I think, anyone here, do you want me repeat it? I explained last time congestion control and flow control, okay? Flow means, can anybody tell me what's a flow control? Yeah, some concern of our speed, okay? You generate data, I process the data. So you cannot just send to me, keep sending data because you are faster than me. You have a bigger CPU or whatever. You cannot just keep sending data to me, overwhelming me. And I'm not able to process this data. You get what I'm saying? So there should be synchronization in the speed between us. Okay, that's the meaning of flow control. And this concept can be hub by hub between every two communicating devices, hub by hub, or also it can be end to end. Okay. Also, this layer is about also reliable delivery of message. That's why when I say reliable delivery, it means error control. I have to make sure when you transmit a packet, it's going to be, this packet is get delivered or message is delivered, okay? So, yeah, sure. What is that? Look, that's what I'm going to explain now. So we have two very famous protocols here. One is called TCP, or Transmission Control Protocol. The other one is called UDP, User Datagram Protocol. You can use either one of them. Okay, so in the transport layer, we have two protocols. You select one of them. How they are different, and what do you mean by select? How they different? I'm going to tell you here. TCP is complicated. This one is so simple. This one almost do nothing. So what do you mean? TCP, it has congestion control. UDP doesn't have congestion control. TCP has error control. UDP doesn't have error control. You got what I'm saying? TCP has flow control. This one doesn't have anything. Just very simple. This UDP is very simple. Okay. So this TCP provides guaranteed. It's guaranteed because it has the idea of retransmission. If a packet is not transmitted, there is a mechanism for the destination to tell the source, I didn't receive message or packet number 7 or whatever, please retransmit it to me. You got what I'm saying? That's why TCP can guarantee the delivery of messages. Okay, TCP has congestion control. The UDP provide nothing, no reliability, no flow control, and no congestion control. Okay, and so that means UDP is so bad, right? We shouldn't. So why they made it? It has nothing. We shouldn't use it. I'm right or wrong? Why? Yes. So the main point, okay. The answer is no, every one of them can be used in some applications. For example, in emails or file transfer, we're going to use TCP. Why? Because I need to guarantee delivery. When you transmit an email, you wanna guarantee the delivery of the email or the file. In this case, you have to use TCP. Okay. However, in case of multimedia, or in case of voice communication, Okay, we're going to use UDP. So why UDP is too good in this case? Number one, in case of multimedia or real-time application, in case of real-time application, you have a stream of data. Okay? So if you miss one packet, still it's okay. You got what I'm saying? So we have a video. In the video, you don't need to make sure every packet or every piece of data is going to be delivered. You don't need to do that. If you miss some data, still it's going to be okay. You don't need to deliver all of them. Okay, so this is one thing. The other thing, because the service, the service provided by the TCP is not for free. There is a cost for that. Okay, so if you want to, for example, for retransmission, it's going to make a delay. To retransmit, it's going to make a delay. They found that in case of real-time application, it's better for the service, for the quality of the service. It's better if you miss some packets. No, I don't need them. It's better for me than waiting for retransmission. So if you wait for retransmission, the video is going to be worse. The quality is going to be worse. You understand what I'm saying? So this is the main idea. So the main idea is that it depends on the application. One of them has almost everything regarding guaranteed delivery, congestion control, flow control. The other one is just too simple. It's too simple, but it has minimum overhead. And this is good because in some application, if you miss some packets, it's going to be much better for me than waiting for retransmission. You got what I'm saying? Because this waiting is going to make the service bad. No, I don't need them. I don't need it. You got what I'm saying? Any questions? So these are two famous protocols. You should understand. I can't say one of them is better than the other. It depends on the application. We can use both of them, but it depends on the application. Any questions? Anyway, so here you can see here, this is the TCP header. You can see in the header here, I have to put here in the header the port number of the source, the port number of the destination. Same thing here in the UDP. I have to port the source port and the destination port. Okay. TCP or UDP, they use ports. Ports means sockets, and they actually again program is communicating to another program. Okay. Any questions? Good. In the next layer, network layer. Network layer, as you will see in this course, it's the focus of network layer is creating routing table. If I want to transmit a packet or from to a certain destination, I need to know where it has to go. Okay, that's it. This is the main focus of it. So here, this one is going to make routing decision to deliver packets from the source to the destination. That is why the protocol, there should be a protocol. In this protocol, you have to create in each router here, you have to create what we call a routing table. You have to create it and you have to update it. It's not only one time and that's it. You need to update it, okay? So that's why you have here a routing table. And then after I receive a message, the router is going to process, is going to look at the address, the IP address here, and then based on the number here in the IP address, the router is going to decide, in order to get this message delivered, should I send this way or this way or this way? How? With the help of the routing table. So I'm going to look, for example, this one here, it has 011. I'm going to look up to a part of the IP. I'm going to come here, 011. So it has to go out from number 2. So I have to send it this way. That's it. Okay. But it has to be globally for any computer in the world. Okay. So I can do it because this one is about globally. Okay. Yes, that's what I told you, and we will understand better in this course. Scalability for sure is a challenge. We have too many computers. That's why the way we made IP addresses is like it has hierarchy, as I explained before. Okay. The next layer, number 2, and also we are going to focus on this layer. It's a very important layer, number 2 here. In layer number 2, number 1, when you receive bits, when you receive just a bits here, the first thing you have to do, you have in the physical layer, you are number one, you have to create frames, what we call frame. So you have to cut, you just from the physical layer, you are going to receive a stream of bits 10 10 10 10. They have no logic. You are not going to give me a packet. No, you are going to get a stream of bits 10 10 0. And then the first thing this layer has to do, we have to create frames. So from 1 0 0, I have to cut it into frame. So I have to identify what is the beginning of the frame, what is the end of the frame. You understand what I'm saying? So I just have a stream of bits. So I have to know, and that's what you are going to explain in one chapter here, how can use this is the beginning of the frame, this is the end of the frame, and then you are going to cut it into frames. That's true. And then you can process every frame. Okay. So again, this as you know, this layer is actually responsible to transfer one hub. So it's actually for the communication inside the same lane, and this one has error detection and error correction as well. So you can detect error. If there is any error in the communication, you can detect the error. Okay. Also, it has flow control. It has a flow control between these two computers. Also, it has medium access control. And that also, this is one of the, I think there is a chapter about this one, medium access control. Can anybody guess what? So this is one of the important things should be done at this layer, medium access control. Any guess? Okay. So it happens in many cases. We have more than one computer, they are connected to the same medium. And no, only one computer can use the medium at a certain time. For example, here, all of us, we share the air. Is that okay? So in case of Wi-Fi, for example, all of us share the air. You have several computers here. What happens if two computers decide to transmit at the same time? Okay, so actually the signal is going to be noisy and the two transmissions are going to fail. So we need a mechanism to make coordination, to coordinate. You can transmit now and no one else should transmit. Why? Because we share the medium. Okay, same thing in case of a bus. So if we have a bus here and we have several computers connected to the same bus, if two computers transmit at the same time, corrupted, the signal is going to be corrupted. That's why we need to access control. We need to control the medium access. So we need a mechanism so that only one computer can access the medium, because if two of them access at the same time, it's going to be corrupted. Okay, so that's what the meaning of it. So this is something very important in network, and this is done in this layer. Okay. Yes. Yeah, that's true. Collision, what is very important thing. So what is the meaning of collision? Collision means two computers are going to transmit at the same time. So the signal is going to be, so very bad situation, because actually we didn't use the link, we didn't use the medium, because both of us lost the medium because we corrupted the signal. Okay. So the last thing here also we have here in physical layer, it's just bits. It's unstructured structure. So let me see here. So we have several protocols we use in the link layer, like Ethernet protocol, like Wi-Fi, and point-to-point protocol. So there are several protocols we use in this layer here. As I told you, the second layer is actually take care of hub by hub. So here we use it here, hub by hub. Okay. The last thing here also, as I told you, the next 3 chapters, okay, are going to be about physical layer. In physical layer, there is no, we have unstructured, so it's not about frames, it's just bits. So the main thing here, if we have here bits, a stream of bits, 1010. I just wanna transmit at the other side 1010. That's it, through a certain medium. So we just a stream of bits. So this layer should we have mechanisms, we have some approaches. When you receive here bits, how can you deliver bits here? Okay. So for sure in the medium here, you can use wireless, you can use wireline, you can use optical fiber. So there are different ways here in the medium, okay? So this one, in this layer, we are gonna talk about data rates. We're gonna talk about something like modulation, coding, something like that, okay? Anything related to, if you have a signal, how can you transmit it from this side to this side? As you see here, we use different media to connect computers together. Like for example here, a twisted pair. Okay, we are familiar with Ethernet. I think we don't use this one anymore, or very rarely used. Coaxial cable. We used it in the past. With fiber optics for sure, it's very famous. Okay, radio waves, Wi-Fi. It's also one of the media, one of the media that can be used to connect to computers together. Okay. So all of this media, you can use it in physical layer to connect to computers together, or computer to router or whatever. Here I'm talking about addressing. I think I already explained this one, the three different types of addressing, like physical, logical or MAC address, and port address as well. Okay. I already explained all of that. So no two computers in the same lane should have the same MAC for sure, because that's identifier. Also, in the same computer, two processes in the host should have the same port address. Also, the same thing for IP. No two computers in the internet have the same. So, for example, here I just want to show you how the MAC address can be used. So here, this is like one LAN, only one LAN. So as you see here, every computer has a MAC address. For sure, just to make it simple, I use just 10, 28, 53, 87. But in reality, it's not like that. It's a big number. It's a big number in reality, okay? It's not a small number, but it's the same concept, okay? So the idea here, we have here 4 computers, as you see here. We are assuming these computers are connected to the same bus. All of them are connected to the same bus. That means if a computer transmits any data in the bus here, anyone else can receive it, because this is a shared bus. This is a shared bus. You got what I'm saying? All of us have access to the same bus. So if anyone transmits, anyone can take it. You got what I'm saying? So what happens here is, as you see here, when this center transmits the data, it has to say who should receive this data. For example, I'm going to put here, this is the second layer. So I'm going to say here, this is the source is number 10. I am the source number 10. I want to get it delivered to 87. 87, raise your hand, 87. You got what I'm saying? So I'm going to send it here to the bus so everybody can hear it. But this one is going to say 87. No, I'm 28. So I'm not gonna receive it. Okay. Here, this is to 87. I'm not 87. I'm 53. So I'm not gonna take it. You got what I'm saying? And then this one is gonna take it. You answer? So because we have a shared medium. Any questions? Okay, that's what happened. Now I think this is one of the most important things here to understand. Very important slide, guys, because here you will see how the MAC, and I can use the MAC and the IP together to get the message delivered from one computer in a lane to another computer in a different lane. Okay, very important. So try to see what's happening here. So as you see here, guys, I'm assuming every computer has two addresses. This one is the IP. Okay, 10, the number here is the MAC. And again, as I told you, I'm using the small number A, B, 10, 20, but in reality, it's a big number. But just to make it, because I'm teaching a concept, not exactly the same thing. It's a concept. Anyway, so what I'm saying here, as you see here, every computer has 2 numbers, MAC, IP. So this is the IP, this is the MAC. Okay. This route, and this is one LAN. In this LAN, there are several computers for sure connected together. I'm just showing here. To make it simple, I'm showing one computer, but in reality, there are several computers here in this LAN. And every LAN should have a router, as I told you before, to connect this LAN to the external world. If there is no router, so actually any computer here, this computer can only communicate with each other, but they cannot communicate with the external world. You understand what I'm saying? So for example, if you see Qatar University, we can have a network here in Qatar. Any computer here on campus can communicate with another computer. But if you don't have a router, you cannot communicate with external world. You know what I'm saying? So That's why you see here, we have, for example, a router here. And this router, actually, it has a connection to this LAN, and it has a connection to this LAN, and maybe has a connection to another LAN here. And for every connection, it has IP and the MAC. So here, like, so this one acts like 3 computers, for example. So this one has 20, the MAC is 20 in this LAN, the MAC is 99 is here, the IP here is F, the IP is T, as you see here, okay? Same thing here to connect this LAN to this LAN, or again, add a router here. This router has IP here, and the MAC here has IP and MAC here. And same thing for this one. It has IP, which is P, and also it has a MAC 95. Is that okay? Let's see if this computer want to communicate with this computer, how it works, okay? So what happens here in the network layer, I'm going to say here, computer A, I'm going to use the IP. Computer A want to communicate to computer P. This P here, and this is A. Is that okay? So in the network layer is gonna say, I wanna here I am computer A, and I wanna send this packet to computer P. Is that okay? That's it. And then I'm gonna send it to network layer to take care of it. How it's gonna be delivered from A to B? It's not my business. I just wanna layer number 3. I wanna send this packet from A to P. And then I'm gonna send to the next layer. What happens in the next layer, as you see here, encapsulation, as I told you, encapsulation. So here, the next layer has to decide if this computer P is one computer here in my network. So I'm gonna use the MAC of this computer to get it delivered here. So again, so after I receive this packet, now there are 2 things I can do. I'm gonna look at the IP, which is P. If the IP, if P is the IP, P is one of the computer in the network here, okay? So I'm gonna get it delivered to this computer by using its MAC. If not, if it is not in this LAN, I'm gonna send to the router to take care of it. So I need to decide now, is this computer one of the computer in my LAN or not? If not, send it to the router will take care of it. Okay, and this is the case here actually. So the case here, this computer is not here in this LAN. So what happens, I'm going to send it to the router. If, as you see here, so I'm going to say this one has to go to number 20. 20 is the router. Okay, so here, the second layer will decide this one has to go to 20. So this one is going to come to here to the router 20. The router will do the same thing. Is this computer one of the computers here? If yes, put the MAC of this computer, and that's it, we are done. I got it delivered. If no, send to the router to take care of it. So that's exactly what happened. So what happened here? So because this computer, so P is not here. So what I'm gonna do, I'm gonna send it to the router to take care of it. That's why I'm gonna say this one has to go to 33. Okay. The last thing, once it comes to here, I'm gonna look P. Is B one of the computer here? The answer is yes. I know P. P is here. P is here. Okay. And so in this time, I'm not going to send to the router. I'm going to send to P directly because I already know P is here. You got what I'm saying? So that's why what I'm going to do here, I'm going to say I know P is here. I know the MAC of P is 95. So I'm going to put here 95. Very important. So there are several things you should understand here. Look here, guys. Number 1. From the beginning to the end, we're not going to change the IP. It's the same. AB. It's gonna when you jump when it jumps from here to here, AB, 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 AB. However, as the packet is transmitted from one network to another, we change the MAC. So you see here, the MAC was 20 to 10, from 10 to 20 to here, and then I'm going to change it from 99, which is here, 99. To 33 to come to here, and so on. So as you see, as it is transmitted, we change the MAC, but IP is the same. More importantly, for what I said here to work, I told you the computer when I receive, I need to know if this computer, if this IP in my network or not. If it's not in my network, I'm going to send it to this computer. If not, I'm going to send it to the router. The router will take care of it. So the question is, how I can know as a computer, how I can know If this IP in my network or not, how I can know? Any guess? What is that? No, there is not switching here. We don't have a switch. A switching table is used with the switches. Routing table was used with routers. You got what I'm saying? So actually, there is a protocol. In this protocol, every computer has like a table, but not a switching table. And this table has the MAC, ARB, right? ARB, okay? So what happens, very simple. Every computer when it joins the network is gonna say hello to everybody. Hello, guys, this is my IP, this is my MAC. I am here, recorded in your table. So we need to know each other. We are in the same network, we need to know each other. You get what I'm saying? So this is done periodically. Every certain time, every computer has to say to the other computer in the LAN, hello, I am here, this is my IP, this is my MAC. That is why I can know if this IP in my network or not. If it's in my network, so I'm gonna just use, okay, I'm gonna use the MAC. If not, so I'm gonna send you to the router to take care of it. Any questions? You understand? Very important slide here. Yeah, it's a lot of thing here to finish this chapter. So as you see here, as that's what I said. So here in the transport layer, we use AJ. So as you see here, A is actually the port. So A is communicating to J. So actually, so this one will be here, this one will be get delivered to here, A and J. For network layer, we are going to use MAC, IP, the MAC is used here. So we use 3 different addresses as you know. Any questions? Okay. So the MAC address is needed here. Okay, that is why when you do decapsulation, you are gonna have A and B here. So you remove one address. So you are gonna have the IP here. So here you have A and J. Here what you need A and J. Okay. Here A and B, A and P. You have here MAC here. Okay. Any question? Okay, anyway, so as I told you in this course, we're going to focus on the first 3 layers, okay, in more details. I think, can we do just in 1 minute? Can we do the attendance, please? Sorry. 7387. No, sorry, wait a second. Yeah, 6128. Let me write it here. 6128. Okay, thanks. So I already posted chapter 2, right? We're gonna start it next time. Okay. Thanks.